with all the walls modeled, let's just take a quick look or a quick recap of the Boolean difference operation. So as you can see, I have Boolean differenced out the windows on the bedroom side, as well as the doors in the first module. And I've mirrored those Boolean objects across and going to complete my Boolean differences. So just as a quick recap, the way that I've done this, or the way that I've rationalized it, these boxes represent the openings of the doors for our bathroom and bedrooms. So they are, in this case, they're an 820 door, and they've got a 35mm frame on either side. So you're looking at a total of 890 mils wide and 2.4 meters high in this instance. Now you could make them 2.1, 2.3, it doesn't really matter, it's totally up to you, but you do want to make them around 890 wide to accommodate for an 820 door plus some door frames. And then you've got this one here which goes into the ensuite. And I've just extended them to be wide across so I don't have to have two of them. And then same with the window sort of follows the same principles we were doing before. And in this instance, I've rationalized the windows to be, these windows to be 2.4 high by 600mm wide. The main front door is 1500 wide because you've got a 1200 wide or 1100 wide door plus a 300mm side light in that instance. And then in the bathroom over here for this toilet, I have a 720 door, so it's a 790 wide box because you have to account for the frame. And then another 890 wide box for an 820 door at the laundry exit or laundry entrance. In the bedrooms as well, everything is relatively rationalized. So the important thing is that there is a small gap, tiny gap, but there is a gap between the two doors, between the two sides of the walls and the doors. It's very tight, but it will do. And then these windows here, these hallway windows, are actually to the center line of the bathroom. So as I'm going through this, if I was doing this as a project and I was just sketching out, yeah, windows will be somewhere around here, doors will be somewhere around here, there needs to be some sort of common principle around it, especially considering that these are modularized compartments that are brought to site. You want to rationalize them so they can be, the same design principle can be copied across. So with that now done, I'm going to go through the actual Boolean process once more. So first thing to do is to type in Boolean difference, in my case just BO, and you can see Rhino is auto-suggesting the command. Hit spacebar, and it's going to ask me what I want to subtract from. So in this instance, I want to subtract from the kitchen walls with the toilet behind, and then when I'm done, I hit enter. And then I click on the box that I want to use to cut out, and then hit enter or spacebar again, and that's now removed. I can do it for the remaining walls as well. So I can, in order to, once the command is complete in Rhino, to reactivate the previous command, you just hit enter or spacebar again. So you can see now it's asking me command Boolean difference, subtract, select surfaces or poly surfaces to subtract from. So in this instance, I'm going to click more than one wall, so I've got my external wall and my internal walls. And then I'll hit spacebar, and now I'll start clicking these boxes. And then spacebar again, and that's now complete. So we now have all of our openings for the entirety of our project. We want to now rationalize our glazing walls, so particularly when we first walk in, we have this glazing wall over here. We then have the two glazing walls that enclose our living space. So again, we want to construct blocks, and we want to try and construct as few blocks as possible to cater for as many solutions as possible. This is no different to real-world principles where you won't want to be manufacturing an individual window size for every single glazing panel. You'd like to rationalize them into maybe 2, 3 different types, and then have those manufactured at scale. So let's take a quick look at how we could break this up. And the best way to do it is to utilize reference planes. So I'm on my reference planes layer, and I'm just going to use the line and the offset tool essentially. So I'm going to draw I'm going to draw a line, and I'm going to draw a line just hovering over this current line. So I'm going to draw a shorter line, just like so. And then I'm going to select that line using the selection menu. So I have this short line, because we don't need to have lines going through the whole project here. And for our sliding doors, this is a 5 meter bay. This bay here, so between this reference plane and this wall, which is this reference line, we have a 5 meter space because it's modularized. So in that instance, we can divide this into 1.666 meters or thereabouts. So in order to move that down, I'm going to click on the gumball and type in -1666 and then enter. And you see that moves that line down. I can then copy this using the gumball as well. So I'm going to click on the line, hold Alt on my keyboard, holding Alt on my keyboard, click the green arrow again, and you can see it takes into account the previous value, and I'll just hit enter. And that copies it going downwards as well. So now we have evenly spaced sliding doors. You have two big sliding doors here, and then the fixed glass panel here, all at equal distance. We also want to account for trying to rationalize the design as well. So a good example would be is that these bedroom walls over here, if you follow these reference planes, we've rationalized our sketch underneath that the kitchen wall would be in alignment with that. It would make sense as well, considering that this depth of the workbench is 700 mil, that this nib wall that comes out here, it would make rational sense that this is equal to the glazing, that this is equal to this wall of glazing here, even though the sketch shows the glazing somewhere back here. Again, it's about trying to rationalize our design as best as possible. So I've kept a 1500 meter gap between this wall and the glazing, and this glazing wall is in alignment with the front of the workbench for the kitchen. So what I would suggest is that this wall over here, this wall here, we keep as one glazing panel. This one here, we need to rationalize as well. So we need to understand where the back of our glazing wall actually sits. And to do that, what I'm going to do is I'm going to take this line here, hold down Alt, click the green arrow, and go -1500. And that's going to be our glazing for this wall here. I think the original is like 1688 or something, but just using round numbers for argument's sake, we'll make that 1500 overhang or a 1500 wide deck component, just for nice even numbers. We'll then divide this area into two, and that will give us 1750. So I'm going to click once here, click once there, click on that one curve, click the arrow down, -1750, and enter. So now we have 1715 glazing panels on either side. And then finally, we're going to break up this glazing wall into 4 glazed components. So again, I'm just going to draw a line just there. Click on that curve, move it to the right. And in this case, it's going to be 1687.5. And then I'm going to keep copying that across. So hold Alt on my keyboard and click the arrow, spacebar. Okay, so we now have our 4 window modules at that length. Finally, we can just double check this by going up to the dimension drop-down menu and just clicking on linear dimension. And I'm just going to click this point to this point. Yep, that looks good. This point to this point. 1750. These ones. 1666. And then this one is going to be one full glazing at 1950. Excellent. I can change the size of these as well by I'm going to hold down Shift on my keyboard, select multiple, go into my properties window and just change the style to small millimeter. There we go, much better. So now we've rationalized what our glazing will be. I'll leave you to rationalize this portion as well. So between this point here and this point here, that 5 meters, I would probably be doing something similar to what we did here, considering this is a 5 meter bay for these sliding doors using 1666. that would make sense. You then have 3 panels in this point here, and again, now we've really only then got 4 different types of glazing sizes if you account for this one glazed wall. If you don't count, that's only 3 different glazing panels that need to be manufactured. With all the window and door openings now accounted for, let's take a quick look at blocks and how to utilize them. So we're going to begin with our standard awning window, fixed and awning windows, which are in each of the bedrooms. So it's 1 block for 4 windows. And if we look at the reference images, or the reference images on Student Web, we're talking about these windows just here. Now if we go to the elevation, we can see its typical design is 1 fixed pane, another fixed pane, and then our awning component just here. You're free to design these windows however you best see fit. There's no right or wrong. I'm going to utilize the design that's already given to us and just use typical dimensions to reference in the creation of these blocks. So the process is exactly the same for all other windows as well, whether they be just fixed glazed, sliding windows, or even the thinner awning windows on this side. Doors are different, and we'll go through them separately. They still utilize blocks, but the easiest way to create them is different to how we're doing this with windows. So going back into Rhino, I'm going to reference and go to my curves layer on my windows. So I'll double click on that layer. I'm going to go to my top view and make sure the project is ticked on, because we don't want to be drawing on any other surface other than our ground surface. So I already have this outline here, which is the 1500 by 2.4 meter box that we use for our Boolean different objects. And I'm just going to utilize this to begin with and offset this by 40 mil. Enter, and then click inwards. So now I have a 40 mil exterior outermost frame. One key tip to remember when using blocks, particularly windows, is you want to use polylines as much as possible and joining lines together as much as possible, if not using polylines. So I'll give you an example of how to join them together as well. So we've got this outermost line here. We then want to have a central frame, so I'm just going to draw 1 line down the middle and offset 20 mil either side. By the way, if you're not getting, when I just click line and I find my midpoint, if you can't find your midpoint, make sure you have the relevant snaps ticked and associated. The next thing I'm going to do is offset a transom from 900 down here upwards. So I'm just going to draw a line, doesn't really matter how long, I'm just going to draw a line from there to there, and I'm going to select that 1 line and then use my gumball and go up 900. I'm then going to offset that 40 mil, and that's now done. So this center line here I'm going to remove, delete, and now we have our basic window frame. We'll then do another offset here as well. So first thing, before I do that, what I will do is I'm going to use the trim tool, select everything, spacebar, and I'm just going to clean these up. Okay, hit escape a couple times. I'm going to select everything and go Control J to join them. And I know now that when I select all of this, if I look in the properties window, I have 4 closed curves, which is perfect. So each of these are polylines. So with this polyline selected here, I'm going to offset this another 40 mil, and this now gives us our awning window, our awning frame. So you can see up until this point, it is essentially drawing windows in CAD. Just lines, polylines, trim, offset, all the things that you're used to doing in AutoCAD. We'll then go to our perspective view, and I'm going to make sure that I've selected all these lines here, and I'm going to go XS, zoom select. All right, and now let's start extruding these out. So I need to pick the internal frames. I'm just holding shift on my keyboard. So I haven't picked my awning frame, just my external frame, and we're going to extrude that and I'm going to turn off project and extrude up 150 mil. So type in 150, that's now done. This internal awning frame, I'm going to select this curve and this curve, and I'm going to extrude that 40 mil. Okay. Last thing to do is I'm going to select this inner curve, and this inner curve, and I'm going to use the command planar surface. So PLANARSFS. So S in Rhino, SFS is short for surface. You might not always see the full word surface. Kind of like how curve is CRV for short. So with those 4 polylines selected, I'm going to select planar surface and then hit enter. And it doesn't look like much has happened. I'm getting this weird sort of graphical effect, and that's because there's like a 2D surface that's sitting on top of the paper, the floor plan. So if I turn off my floor plan, you can see that's what it looks like. Okay, so that's our glazing. And then what I'll do, the final thing I'll do is I'm going to select all 3 of those glazings. I'm going to zoom into this corner here and move them upwards. I'm going to move them to halfway through that the awning panel. So I've moved them 20 mil offset back. Now of course glass has a thickness, but you know, in this instance for a design model we're not going to worry about it. It's just going to be a planar surface. The last thing to do is I'm going to select the solids, and I'm being very careful to select only the solids, and then I'm going to right click on the solids windows layer and say change object layer. So they turn green, and I should see all my orange curves underneath, which I do. So what I'll do now is I'm going to double click on the solids layer. I'm going to turn off the curves layers. This way I know I'm not selecting any lines at all. Alright, the next step is to actually block this item. So I'm going to select all of it, all those objects. This works much like AutoCAD. First thing I'm going to do is I'm going to rotate this 90 degrees upright, and then type in block. It's going to ask me to pick the point, the insertion point for the base point of the block. So I'm going to pick this bottom corner just here, and then I get the block definition properties. So in this instance, this will be our 1500 by 24 window, and then enter, and that's now complete. So when I select that, that's coming up now as one selection, and you'll also notice that under the objects, under the properties, the object is now defined as a block called the 1500 by 2.4 window. Now it's as easy as just clicking on this block, using the move command, and going from point to point, and they'll fit perfectly within the space. Now we'll clean these up a little bit later. There's still a lot of work to do around these walls, but for now, just putting them into place is fine. So I can copy them across. I can just go from point to point. I mean, I could also take both of these and then mirror them as well to this line just here. So I can click once, click twice, mirror. Oops. Had a bit of a heart attack there. Mirror from that center point there across, and that's now complete. So that is how we create windows and block them. The process is exactly the same for our awning windows on this side of the building, and finally for our curtain or our glazed walls, the process is actually easier than what we just went through. So going through one of those, I'm going to turn back on my window curves layer. In fact, I'm going to go back to my windows curves layer. I'm going to go to my top view, and let's do one more. So use a polyline. Just use this as a smart track, and then come across. It doesn't even matter really which one I use. I'm going to use the 1687.5. 1687.5, enter. Okay, remember, that's actually it's a good issue I just had. So I'm clicking on these lines and I'm getting very odd responses. I was getting like the distance between here and here was 3 meters, but my project button is not ticked. So I could easily have been accidentally picking a point somewhere up in space and then creating a diagonal line down. So it makes the line appear longer, even though in top view, it looks like the line is the same length. It's a little bit trippy and it can trip you up very easily. So make sure if we're drawing in 2D, always have project ticked on. Alright, so let's go again. Okay, so that's our outer line, offset, $40 mil, and then we're going to go to our perspective view, and I'm going to extrude those, and in this case I'm only going to extrude it probably around about 40 mil. And I'll take the inner surface, or the inner curve, and use planar surface, and then I'm going to move that surface down 20 mil, because the frame is 40 mil thick, so I'll make it half the distance. And we can reference this too. If we take a look at our example, we can take a closer look on what we think the glazing is like. So yeah, I would suggest it's probably like a 40-50 mil frame. There is no right or wrong. You can make it whatever you wish to. So if you think that is 40 mil wide, that's fine. If you think it's 40 mil high, you might think it's 50. You might think it's 150. It's completely up to you. It doesn't really matter too much. But we're doing these windows currently over here. But the process is exactly the same for these two frames here and here. And then for the sliding doors, it's basically the same thing because they're full height. They go from ground to basically ceiling, which in this case, this ceiling turns into the overhang, the eave overhang over the top of the deck. So with that now complete, I'll take these two surfaces, change them to solids, hide my curves, rotate this up 90, block this, turn off project, click on one corner, and in this case this is going to be our 1687 by 2.4 glazing window. That's now done. And now with what I can do is I can bring this using the move tool. I'm going to bring this back up to ground level. Turn on project. I can just select this and I can use my move tool just to snap it into place. And then what I'm going to do is I'm going to turn off my reference planes and I'm just going to copy this using the copy tool. Turn on my reference planes again. And there's our glazing panels just here. Now here's a good example of where I find later on you might find this too, where I drew these references and I drew them up in space. You can see they're not sitting on the floor, and that's because I started by tracing over this wall, and I obviously didn't have project turned on, and I drew on the top of this wall. So when I offsetted them up here. But in top view, you don't notice that. You can't tell until you go to a perspective view. So to get these on the ground is actually relatively easy. I'm going to select these lines that I messed up. They're still the right dimension, but they just didn't sit the right place. And I'm just going to type in project to C plane, and then hit enter, and then hit Y to say yes, I want to delete the current ones and push them to the floor, and then hit enter again. And now you can see those being pushed down to the ground floor, and our windows have lined up nicely with those markers. So the process is the same for the remaining of these glazed walls. And then for sliding doors, you can just sort of push them across. So, for instance, where the sliding doors are, if these were sliding doors, you can push one downwards and then inwards behind it. And if that was like a double sliding door, it looks something like that. You end up with a look similar to that in that case. In terms of adding materials, and glazing and making those transparent, we'll cover that in a later video. For now, just get your windows all together and put into place, and then we'll move on to how to create blocks for doors. With a basic understanding of blocks and how we utilize them to model windows, let's take a closer look at doors and how we would go about modeling a typical standard door. So first thing to do is I'm going to go to my reference planes layer, go to my top view, and we've got our windows we've been working on here, and next to that I'm going to just draw a line there, and I'm going to offset that 820, and then I'm going to copy .35 one side minus 35 the other side. Okay, and then I might just do one going across here, and then offset that 100. Okay, so this is the basis for our door, and we're not quite finished yet. Oh, actually that will be enough to get us started. Okay, so what we're going to do firstly is we're just going to create a new layer, and we're going to call this one doors in caps, and then as we've done with the other layers, a subcategory for curves and another one for solids. And again, we might make the curves red, and we'll make the doors, actually we'll do the opposite, we'll make the solids red and the curves blue, so opposite to walls. Okay, you can make them whatever color you want, just make sure that the curves and the solids are two different colors, so it'll become very clear if there's anything that's not on the appropriate layer. So I'm going to take a polyline, and I'm going to draw one of the doors. It would help if I was on that layer. Do that again. Start from here, come down to at the halfway point. So that would be 50 mil down. And I'm going to come out, say 15 mil. Down 15 mil. Come back across, cross, cross, and now done. Now I'm not too happy with how this looks, so we can edit polylines at any point because they are one closed curve. We've got these little dots that you can see here, they're called control points, and we can select them individually to manipulate and move this object around. So if I select this this door jamb, this nib is way too small at the moment, so what I can do is I can select using my left to right selection. I can select just those 2 points, and now you can see I'm just moving those, which will in turn make this nib bigger or smaller. So in this case, I want to increase it 15 mil, something like that, and that now works perfectly. The same applies anywhere else. So if I go and grab this curve, I could, for instance, grab these two, and I could drag them in and out. I could click on this, and I might just click on one of these points and move them. I could even click on one of these points and delete them. And so we'll go from that point to that point, missing this point that was previously there. So there's still a lot of editing you can do to polylines once they're complete. In some instances, manipulating polylines in Rhino is actually a little bit easier than CAD in terms of utilizing those control points. So we've got the door jamb sorted on one side. That is fine. The last thing we need to do is another polyline for our actual door leaf. So I'm just going to start from this point here and move my way back, which is 35mm. That's perfect. It's basically the standard thickness of a door. Come across, go across again, back to the start. So this is actually our door ready to go. So you might be thinking, all right, so you have one door jamb on one side, but where's the other door jamb or door frame on the other side? Well, what we're going to use is we're going to utilize a new command called sweep1. And that will create our door frame. So what we need to do is we need to go to a top view of some sort, sorry, a front view of some sort. So I'm going to go out of here and I want to see, we'll go down to here and let's change this to set view and then front. And I'll change this back to shaded mode. Okay, so that's the opposite side. We're looking currently at the back of the house or the front of the house where the front door is. So let's change that to set view back. Okay, that's better. So there's all those windows that we've been drawing and the window wall there. What I'm going to do is I'm going to make sure I've got project on, and I'm just going to come to an empty place in space so I don't accidentally draw over anything. And I'm going to use a polyline, and I am just going to start anywhere around here, and I'm going to go up 2.3 meters or I'm going to do 2.4 because that's what I've been doing consistently, but you know, you could do 2.1 or 2.2, 2.3. This is the height of the door, and then I'm going to click and then come across 890 because that's the total opening, and then come back down, and then that's it. Hit enter or hit spacebar to finish the command. Now, if I go back to my perspective view, you'll see now there's that line we just drew in space, and it's offset from our doors. So what I might do is I might just pick these lines up over here, and I might zoom in. I'm going to zoom in and I'm going to move them from this front point here. So click move and then snap it to that point there. Okay, and if I'm having trouble zooming around, which I am, I'm just going to select one of these objects and go XS, zoom select. So now it becomes the center point of my rotation. So zooming on this point, if I remove the reference planes, you'll see that this line here is basically what that is the path, or what Rhino calls the rail, in which this object is going to be extruded along. So it's going to extrude it up, extrude it across, and then extrude it back down, or in real terms it's called a sweep. So it's going to sweep it up and across and down over this rail. This is the rail or the profile. And then we have our door leaf, which we'll just extrude up, and that is just an extrusion. So let's give this a go. So I'm going to use the command sweep, and there's two types. There's sweep 1 and sweep 2. We'll look at sweep 2 later on in a little bit more detail. So sweep 1, spacebar or enter. Select the rail, so these are the rails, and now it's saying select the sweep shapes, and that is the door jamb. And when I'm done with that, hit enter, and then it's going to give us an arrow to tell us in which direction, so it's going to be inwards, which is correct, and then hit enter again, and then you're going to get these sweep 1 rail options, whether the form is road-like or free form, whether you want to rebuild the cross sections. Generally, I just leave it as is. I just say okay, and that's done. And you'll see now that has taken that shape and extruded it up, across, and down as a door jamb should be in one command. Very, very easy. Then all we have to do is take these curves here. Actually, what I'll do is I'll change this to the solids layer so it becomes very obvious. Okay, so that's our solids. I'm going to take this door leaf and just use the extrude command and then just push this up. And what I'm going to do is I'm going to make sure project is turned off, and I'm just going to hover my mouse over the top of the door jamb. And what that allows me to do is I don't need to type in a number. I can just hover my mouse there, and you can see at the bottom of the screen, just down here, it will just tell me the reporting number. So it's 2.365 high is the door leaf. Just click, and now that's complete. Okay, now look, again, this is a design model. So in actual fact, you're going to have slight gaps at the top, slight gaps at the bottom, all the rest of it. But for argument's sake, for the sake of this project, we're just going to leave it as is. All right, and then I'm going to change this to a solids layer. Now the last part is putting on a door handle. This is again, we're going to use some other commands. We're going to use the sweep command, and we can also utilize the revolve command here. So depending on what type of door handle you want to model. So what we're going to do is, we're not quite done here yet. I'm going to go back to my top view. I know there's my door away from the building. That's fine. We're going to model a door handle. So I'm going to go polyline. I'm just going to draw with project anywhere in space. And I'm just going to go up maybe 30 mil, and then across maybe 100 mil, and then click. Oops, I'll do that again. Up 30 mil, across 100, and then enter to complete, or spacebar to complete. Okay, so that will be our door handle. What we need to do now is go to our perspective view. Okay, and there's our door handle. I am going to utilize a circle, so I'm going to go up to my circle tool here, and if I just draw a circle and I go like this, you see it's drawing it on the floor. So I can rotate this like so, and then I can move this. And at this point, it's a little bit hard to move because I have project on, so I'll untick project. And I want to make sure that I have center turned on. So this way I can actually pick up the center point of my circle, and I can move that over to here. Okay, so doing that again, I can pick this up. I've got center selected as my snaps. I haven't got project on. I can click on this circle, hit move, find my center point. You can see it snaps, and then just drag it to the end of that line. I can then change the size of this circle as well, which I will do. I'll hold down shift. So what I'm going to do is, I'm clicked on the circle, I'm going to use the gumball, which are these dashed lines just here. So I'm going to hold my mouse over the square, hold down shift on my keyboard, and then just move my hand so it makes the circle smaller. Now, how big that is, I'm not sure, but we could use the scale tool as well. So I might use scale, just the first one, scale, and I might click once to start, once to end. So it's currently 26 mil across, and I might put in there, more of a round number like 25, and then hit enter. All right. Last thing I'm going to do is, I'm going to go back to my top view, and I'm going to fillet this curve here. So much like in AutoCAD, just type in fillet, and I might fillet this, say 10 mil, and I'll just click once there, that fillets that off. Back to my perspective view. And in fact, I think this is going to need to be smaller. So I'll just shrink that down a little bit. And we'll use the sweep command again. So sweep 1, enter. That's our rail. That's our profile. Enter and enter. Okay, that's fine. And that is our door handle. All right, but I think we need to do some editing. We want to probably make this a little bit bigger. So what I'm going to do is, I'm going to go to my top view. I'm going to click on this line. I'm going to click on this point, and I'm going to move this downwards, maybe another 15 mil. And I can take this, make sure project is on, and I'll move this door handle profile back as well. I'm also going to move out this door handle a little bit. I'm going to move this out plus 20. All right, and then again, I make this a little bit smaller. And and then use the same command. Sweep, rail, profile, enter, enter, done. Okay, but you can see that's currently open. You can see through that pipe. So you can click on that and you can use the command called cap, and that will do exactly that, caps off the ends. All right. Okay, so last thing to do is to add a base plate to this. So the best way to do that is to, we could use maybe a new command. We can use revolve. So what I might do is I'm going to go to my top view, and I'm just going to draw a profile. So I'm going to go polyline, and I'm going to make sure project is on. I'm going to start from the center of our handle and come out, say, maybe 30 mil. Hit enter, click, come down, maybe say 15 mil, not even, maybe 12 mil, enter, and then come back to the center. It's important I come back to the center and I finish that off, so it's just a rectangle. And then what I'll do is I'll fill it 5 mil radius, this corner here and this corner here. So that is 1/2 of the profile. So I'll go to my perspective, zoom in, XS, okay, and let's try the revolve tool. So type in revolve, select curves to revolve, yep, that one, enter, and then the axes will be from this point here going back towards the door handle to there, and then enter, and then saying, would you like it to would you like the revolution to be a full 360 degree? Yes, we would. Enter, and that's now done. So you can see it's taken that curve and essentially spun it around itself to give us this 3-dimensional shape. So I'll click on these two solid objects, and I'm going to make sure they're on the solids layer. Okay, so we don't want to get our curves mixed up. All right, so with that now complete, I'm going to firstly, I'm going to uncheck the curves layer, so they've turned off, go back to my solids, because I don't want to accidentally select them. And we're going to actually use a block in a block. So the first thing I'm going to do is I'm going to block the handle, so type in block. It's going to ask me to give a base point, and my base point is going to be the center of the door handle. Honestly, it could be anywhere. I'm just going to call this door handle type A, and that's now done. And now using some, with project on, making sure I got project on, I'm going to turn this into wireframe mode, and I'm just going to move the door handle from this point here. We know that my, to that point there, and we know that this surface here, that is our door leaf. So that's where the handle is going to be attached to. So I'm going to move this out. That point to there. Or in fact, I'm going to take this point to the end of the door, and then I'm going to move this minus 50. Whoops, it should be plus 50, so make that plus 100 now. Something like that. So the door handle is just about there. In fact, I might move it in a bit more, maybe plus 25. Actually, let's just do that again to make sure it's nice and clear to everyone. So I'm taking the center of the door handle and putting it over the corner of the door leaf. I'll then click on the door handle and then use the move tool, and then I'm going to move it back, maybe let's move it back 60 mil, and then hit enter. And then I'm going to use my mirror tool. Well, actually, before I do that, I'm going to go to my front view and my back view. So it doesn't really matter which one of these views, because we're in wireframe mode, it doesn't really matter. I could even go to my side view and then just click up on the gumball and type in 1000, because that is your typical height for a door handle. So if I go back to like my 3D view and go to shaded mode, you'll see now the handle is on that door just there, like so. And then the last thing to do is to go to my top view and use mirror. And mirror, and then find the center point. Well, if actually I need this back to wireframe mode because I need to find the center point of the door leaf, which is this point just there. I move my hand out this way and click, and now we have the door handle on both sides of the door, like so. Okay, like that. And then what we're going to do is we're going to click on this door handle, click on the door leaf, orbit around, and click on the other door handle, and we're going to group them. Okay, so that's now grouped. And the reason why that's grouped is because if we want to spin this door, we want to make sure that the door handle goes with it. Okay. And then the last thing we're going to do is I'm just going to take this door, and I'm going to leave this and this separate for now, because we might want to spin some of these doors, and other doors we may not want to spin or open. So, or actually no, what we'll do is we will open it and then we'll block it open. So again, I'm going to go to my wireframe mode. I'm going to click on my door leaf, which is actually now a group because it has the handle with it. You can see that there. And then we're going to use the rotate command. So I'm going to type in RO for rotate, enter or spacebar, and it's going to ask us to pick the center of rotation. So the center of rotation is going to be from this corner back here because that's where the hinges on the door are. So I'm going to click that and move my mouse over to the other side of the door. And now you can see as I move my hand, well, actually we're in ortho mode at the moment, so I'm going to make sure I turn ortho mode off. You can see that it's as if the door is actually opening. Okay, all the way back to the hinge point. And in fact, that's not quite right. We want to rotate it from the outside of the door. So let's do it again. We'll go here. It will be from this point here, not this point here, because the hinge sits on the outside of the door leaf. So I'll click there, move my mouse to there, and that's better. Okay, so if it's fully open, like we see in the CAD drawing, that's how it looks. But what we might do is we might just give it a little bit less. So instead of rotating at 90 degrees, let's maybe say 85 degrees. In fact, we'd have to go minus 85 degrees and then hit enter. So we go back to perspective view and turn this to the shaded mode. This is what we end up seeing, something that looks like this. Okay, so with that together, I now select all of that, block it, pick my base point. So I'm just going to pick one of these corners, and then I'll call this 820 internal door. All right, so that is one door now complete. So I can go back to my top view, I can go to my wireframe mode, I can take this door, and I can start moving this around. And because I already know where my openings are in here, we can just play the game, just rotate 90 degrees, and then I want to rotate this actually 180, so it looks like that. And then just making sure that project is on, so I don't accidentally snap it anywhere I don't want. It's just a case of moving this to that little nib there, and that door is now in place. And then I can just use the mirror command and mirror it from the center point of this wall, or I can take the center point of this window because I know that's in between the two doors, and that's now in the correct place. And then I can just copy that across to this over here. And if the door is the wrong way, so if I give you an example, if I take this door, just copy it, I can rotate it 90 degrees and then 180. So in the bathroom, that is actually correct. The door would open in that direction. But if I wanted to flip it, let's say the door was on this side, all I have to do is just mirror it in that spot. So I just click on mirror, hit enter, and then I just go to the center of the door and go like that. And then I can just delete that one. And now I have a door that opens up to the right rather than to the left. Okay, so if we go back, I'm just going to take this door and move it into place. So from that point there to that point there. Looks like a bit of a line mess at the moment, but if I go back to shaded mode, you can see how that's nice and clean. We now have doors with our door jambs, with door handles that are open into each of these rooms. And that is more than enough to show design intent. Now, if you want to change the frame type, that is as simple, I'll turn back on the curves. So here's our curves over here. That is as simple as just changing the profile of this door frame. So if you don't want a double rebated door like this, it would just be a case of taking this point and deleting them. Well, actually, or the other thing we could do is we could take these 2 points and just click move and move them back to there, like so. And then you could then use the sweep command. So sweep 1, rail, profile, enter, enter, done. And so that's a single rebated door. If you want to change the door handle profile, you can do that too. So in this scenario here, I'm using what's known as a lever door handle. But if you wanted to change this shape into another shape, you could do that. If you want it to be an ellipse shape, which would be rare, but if you did, you could do that and then use the sweep tool. So again, sweep 1, rail, profile, enter, enter. Okay, that could be a rectangle, it could be a square, it could be whatever you want. And same with this revolve. So if you want this revolve, in this case is just a rectangle with a filleted edge, that's fine. But if you wanted to do something that was a little bit different, revolve is always going to give you a circular shape. But for instance, maybe you want something that looks like this, a little bit more detail. So I got project on. Okay, we're saying with like an indent, I can use revolve. That's the curves I want to revolve. Hit enter. I want to revolve them across this axis. Hit enter and enter again, and you'll end up with something that looks like that, as an example. So with that now complete, those doors now complete, or those internal doors complete, it's up to you to take that same method and apply them to all the internal doors. Now, if you want to keep some doors shut and other doors open, that is fine, but just note you'd have to make 2 different blocks because the blocks are that the doors are open. So if I was to open this block up and edit it and close it, as soon as I save that block, all the other doors will also be closed. So just keep that in mind. And then as for your front door, you can have a little bit more freedom there in terms of how you want to design it. If you look at the example, you've got like a front door itself, and then you've got the side light. So generally speaking, the width of this, we've allowed 1.5 meters, and you may decide to say, all right, well then my actual door itself is going to be 1.2 wide or 1200 wide, and this might be 300, or you might say this might be a meter wide and this could be 500 wide. It's up to you. I'll leave that up to you and how you want to design that. And then in terms of the door itself, the door leaf, in this case it's a glass door leaf. The only difference there would be is you would draw that door as if it was a window, essentially. So instead of using a door frame like this that's just extruded upwards like we did before, what you could do is draw your door leaf on the ground like this, and then use the same method we use for glass, and then just rotate it, turn it up, and then stick it into position. There's quite a lot of freedom that you can do, that you can use here, and really it's just your imagination and using those same tools in terms of the design you want to use. So there'll be a bit of time for you now to catch up, because this is probably as model intensive, as complex as it gets before we move on to joinery later in the course. So you'll have time now to catch up. But by the next class, you want to have absolutely all your walls complete, all your windows should be complete, and you should be modeling away on your internal and external doors.